All right, let's go ahead and get started. Any questions on anything before we get back into volume here? All right, so so basically what I want to go from here is we've talked a lot about the disc method, washer method. By the way, somebody asked me to do this before class. Basically, those are kind of the washer method on top, shell method on bottom there. But basically, these are the two approaches we have. The disc method is basically a specific case of the washer method. But now that we've talked a lot about both, let's try to get away from like jumping into any given example with like a preconceived notion. Like now we can figure out which one makes more sense to do. So if I want to find the volume of this thing here, just as I said, it says to use the shell method. I'm cutting that out. Maybe it makes more sense, but let's find it out. So we want to find the volume. I don't really care how. How should we start? Yeah, so let's try to visualize it. That doesn't really change whether I do the disc method or the shell method. So I'm going to take the square root function bounded by the x-axis, the line x equals 4. So x-axis, y-axis, x equals 4 in this curve. So there's the region I want. Where is it being rotated? Around the y-axis? Okay, so rather than ask you what kind of method you want to use, I'll ask this instead. Do we want to do vertical rectangles or horizontal ones? Got to vote for vertical. So let's do that.
Because if you did horizontal, it would be thin, right?
If we do horizontal, so since we are going to do vertical, let's at least see what the shapes are that make out of this. If I do a horizontal rectangle, what is going to be made if I wrap this rectangle around the y-axis? Is that going to be a washer or is that going to be a shell? I can't really show it on the other side of the axis with as little space as I gave, but basically if I revolve this area, I'm going to have all this mass in here, right? So that's not going to be a thin shell. That's going to be a solid disc or a solid washer. So that combination right there, basically, I am mandating that we rotate around the y-axis. If you choose to make dy rectangles, you are opting for the washer method, which is fine. We can do that, except that first person chime in said vertical rectangles, so let's look at those. So this is a dx rectangle, right? If I rotate that around the line I want to rotate around, what's that going to do? What's that going to make for me? That'll be a thin cylindrical shell. So tall rectangle, thin cylindrical shell. But basically, and the words I'm using there are vague, but when I say things like thick and thin, in this case, what is the thickness of that cylindrical shell? Dx, right? As opposed to if I'm making a disc, that just comes from, a larger thing. I'll call it delta X. So like if I put my horizontal rectangle back in here, if I wrap that around the y-axis, where's the thickness of the shell, or where's the thickness of the washer coming from? It's coming from whatever this big change in X is. So that's really what I'm getting after when I use those vague descriptors, thick and thin. Are you getting that dimension from the variable X, which is like a large change in that variable, or from dx, which is a very, very small change in that variable? So this right here tells me I'm making shells. This right here tells me I'm making washers or discs, depending on whether you have that hole in the middle. So,
It's frozen.
sorry?
I think it's frozen.
Awesome. Hopefully it comes back. Okay, so I'll filibuster for a little bit while it's not updating. So we decided to do vertical rectangles, and I decided that we are wrapping around the y-axis, right? So we're going to use what method? Shell method, right? Come on, come back. So how do we set up shell method? Okay, so basically I'm going to use that bottom thing there. The volume is equal to the integral from A to B, whatever it makes sense for A and B to be equal to, of 2 pi times the radius times the height dx. Is it back yet? Cool. Here we go. All right. So now we're up to date. So now we got to use the shell method, which this is the integral to set that up. Now what do I have to do with it?
What's your bounds?
What are my bounds?
Here.
0 to 4. How do we know those?
Your X values.
They are X values. So we are doing a dx integral, which means my bounds need to be left and right X values. All right, what else do we need? What is the radius in our case?
Right.
So we got to vote for X, vote for Y. Let's fight it out. We're integrating dx, so let's just talk geometrical definitions here. We're talking about cylinders. For all these volumes we're doing, we're talking about cylinders in some respect. What gives you the radius of a cylinder? Like what, if I asked you for the definition of a radius of a cylinder, how would you describe that to me? Distance from the center to what? The distance from the center to the outside, the circumference. But that distance comes from this vertical line to this other vertical line, right? The distance from a vertical line to a vertical line, is that something you measure vertically or horizontally? It has to be horizontal, which is why it has to be an X value. It might not always be X, but it's going to involve your X value somehow. In this case, does it make sense? The radius is simply X.
Simply going to be the opposite of the axis you're flipping over.
Right. It's going to be the variable that does not describe the line you're looking at. Yeah. So basically what I'm doing here is I'm comparing this X value to what's the X value on the Y-axis? X equals 0. So basically whatever my X value that I'm allowing to change, minus 0. What about the height? Where's the height going to come from? Square root of X, or basically come from a Y value, right? So something I don't actually know if I've noticed before. Are the radius and the height always going to come from opposite measurements. What I mean by opposite is if one comes from the X direction, the other one has to come from Y. Should that always be true? That should always be true. So I have my radius, I have my height. Now I think I can fill in the rest of this integral from 0 to 4 of 2 pi x radical x dx. Is this an integral we can do? Maybe we'd like to simplify a little bit.
You take out the 2.
I can. So 2 pi times the integral of x to the 3 halves dx. What is the integral of x to the 3 halves? 2/5 x to the 5 halves. What is 4 to the power of 5 over 2? 16? 32. So 2 pi times 2/5 of 32 minus 2/5 of 0. So all told, I should get what? 32 times 4 is 128. Go ahead.
So if we were rotating around 5, the radius of x minus 5.
If we're rotating around where? X equals 5? That's a good question. So instead, if I rotate over this line here, so if I rotate over x equals 5 instead, what would our radius be? 5 minus x. Does that make sense to everyone? I would bet money that someone in here is thinking that it might be x minus 5. So let's talk about that. Does it matter, first of all? Why does it matter? Well, ooh, I forget it's a touchscreen. Can't just wipe things off of it. So x minus 5. By the way we've defined everything, all these x values are less than 5, right? They're strictly between 0 and 4. So if I subtract 5 from that, you're going to wind up with a negative radius. So yeah, 5 minus x is what I would really prefer for that.
With any of these volumes, if you're getting something negative, that should let you know you're switching.
Yeah, so I mean, if you're getting a negative, it might tell you that basically flip the sign and you have your volume, provided you did everything else correctly. But yeah, that should be a red flag that if you get a negative volume, that should be a clue that you defined something incorrectly, or that there's an error somewhere. Any questions about this one here? Okay. So now that we've talked a lot about both these methods, let's talk about here. So how do we know which is the best one to use? What kind of factors go into making that decision?
Which one is possible?
Which one's possible? So sometimes one will be impossible. What if that's not the case? What if they're both just like equally doable? Does it matter which one you do? At that point, it becomes a matter of like personal preference. So the bigger thing I want to talk about here is this relationship. So basically, I kind of said that when we do these volumes, you have to answer 2 questions. One is, what kinds of rectangles are we dealing with? Dx or dy? And the other kind of thing is usually a question that you can't answer. Usually it's a question that I'm going to mandate for you. Is it a vertical or horizontal axis of rotation? So given that those are the 2 questions you have to answer, how many different possibilities are there for setting this up? Should be 4, right? Either I have dx or dy rectangles, or I have a vertical line of rotation or a horizontal line of rotation. So let's just talk about all four of them. If I have a vertical line of rotation and I'm going to take that. So if I have DX rectangles, so tall, thin rectangles, and I wrap those around a vertical line, does that lend itself to making shells or to making discs? Those are shells, right? So let's move over to the right. Actually, let's stick with DX rectangles. I still have DX rectangles, but now I'm going to wrap it around a horizontal line. What does that make? That's a disc. Disc or washer, depends on whether you have that hollow inside. Okay, now DY rectangles, so long, flat, thin rectangles. If I wrap those around a vertical axis, what am I making? Disc or a shell? Disc or washer? And finally, if I take a long horizontal rectangle and wrap it around a horizontal axis, what does that make? Shell. And basically, depending on what the situation calls for. So whether you're wrapping or pretty much, you don't get to decide what line you're revolving around. It is me who decides that. So the decision you have to make is basically what kind of rectangles do I want to do my calculations or do my integration based on, and that is going to lock in what method you use. Does that make sense there? Does it help to put kind of a bow on it like that? Okay. So yeah, in many cases, the choice will be yours. Really, I think I hesitate to use the word easy because I don't believe any of this is easy, but those situations where Caleb talked about where the integration is not possible under some circumstance, basically the decisions are made for you. So let's do the y-axis first. So I want to revolve this thing, this shape that or this region I'm talking about around the y-axis first. How should we do it? How should we start? Let's graph it. I don't really have a great idea what this graph looks like. I know it's a parabola, but that's as much as I feel confident about. Can I find where this thing crosses the y-axis or the x-axis? Okay, so let's do that. So 0 equals negative x squared plus 6x minus 8. That's the same thing as saying x squared minus 6x plus 8 equals 0. Does this factor? Positive 2, positive 4? Or the factors come out like this, which means the roots are 2, 4. Does this parabola open downward or upward? How do we know that? Negative squared term. So basically I have this thing here, right? And we're going around the y-axis. Okay, I think I have a good idea now what the job is. I want to rotate those over the y-axis. What else do we have to figure out? Yeah, what kind of rectangles do I want? Why is dx better? Don't have to solve for x in terms of y. That's true. So I think that alone is a good enough reason to do dx rectangles here. The other thing I'll point out is this. For a parabola, for that parabola, is y a function of x? In other words, if I pick an x value, will I get exactly one y value back? I think for the direction I'm talking about, the answer should be yes. I give you an X value and you calculate this. I'm only gonna get one Y value, right? But going the other direction,
Yes.
so Y is a function of X. X is not a function of Y. So I think that's another really good reason to use DX rectangles. So then, am I doing shell method or disk method? Also, basically the choice I made for you, which is this, and the choice Clement made, which was DX rectangles, that combination makes the shell method a requirement, essentially. So the volume is equal to 2 pi times the integral from a to b of the radius times the height. Do we know the bounds of this thing? What are they? 2 and 4. What's the radius? Radius should be x. Why is it x and not something like x minus 2 or x minus some other non-zero number?
It's Y is here.
Not that y is 0, x is 0. Y-axis and x equals 0 are, yeah, it's a different name for the same thing. What's the height? Right, so the height is a y value, but I don't want to write it as y. I want to write it as how it's defined in x. How are we doing there? Go ahead.
Can you explain a scenario that wouldn't just be X?
Yeah, or I'll put it back on you all. So give me a situation where the radius would be something other than x. Okay, I heard a lot of things. Evie, I heard you first. What was your answer? If I rotated around x equals 1, for example, if I did that, so basically I'm sliding the axis rotation over one place to the right. If I do that, what's the radius I use here? I heard a vote for x minus 1. Does that make sense? So now, now that I have the rectangle drawn, let me actually give a, let's call this thing A. Whatever this x value is, I'll call it A. What's the distance from this place to the original axis I wanted to rotate over? No, where are we starting? It should just be A, right? So yeah, so I gave that specific x value is A. But if I wanted to measure the distance from that place to the y-axis, that's simply A, or A minus 0. How far apart are this and the new line? That's A minus 1. So basically, the way I would get my radius for that new line, I'm going to compare whatever my x value is to x equals 1. So that's why I take that difference. So yeah, basically, your radius is going to be something a little more complicated than simply the variable whenever you're rotating around something that's not one of the coordinate axes.
For that particular example, you need the thing you're rotating around to be before your function.
Yeah,
Say
so
it was like x equals 5, then you would have to
right,
do
so
the other way.
like so the other possibilities here is 1 minus x. If I do 1 minus x, what do I know about all the x values in here? They're between 2 and 4, so they're bigger than 1. So because of that, I want to subtract, and the rule of thumb that I encourage y'all to think of it is make sure whatever subtraction you use is going to give you something positive. So because of that, I want to put my x value first, because those values are going to be bigger than 1. Really good question. But really, it's an important thing to pay attention to in those cases where it shows up. Any questions on here, Sebastian?
If you were doing around X equals one, we also have to change the height.
It's a good question. I actually didn't want to talk about that. Do we have to change the height? I think the height should still remain. So one thing I did not write here is that I think the radius is equal to X and the height is equal to Y. Not always, but in this case, I think that has to be true. So the reason I write that down is because if we move the line of rotation, which is still a vertical line, that has nothing to do with how tall these cylinders are going to be. So I'm going to keep that. So I believe this integral is something we could do. I'm going to go ahead and stop this one at the setup. Questions here? All right, so let's reload this one. I want to wrap around the x-axis now. So same graph. So same graph, same region. The big change I'm making here is I don't want to wrap around the y-axis anymore. I want to wrap around the x-axis. So what are we going to do?
Rectangle will be dy.
We'll do dy rectangles. How come?
Because it's the opposite of what we did.
It's the opposite of what we did.
For DX.
Why would you prefer dx rectangles?
It's still the same problem of not actually being able to
Right.
make the horizontal rectangle.
And this is kind of what I was hoping to point out with doing this example two different ways. The question you're answering for yourself, I suspect, is not really whether you want to do the disk method or shell method. It's typically going to be what variable do you want to fight with. So let's go back here. When we set this up for, I believe, I don't remember for sure, but I believe we said dx rectangles for this before we ever talked about disk method or shell method. And let's recall here, what are the reasons we said for using dx rectangles here? We don't want to solve for y.
I mean,
Yeah, sorry, yeah, you don't want to solve for x to state this in terms of y. This is one of those times where it's totally possible. I don't want to do it though. But that right there, that reasoning, which I said was better than good enough at the time, it has nothing to do with disks or shells. It's all about what kind of integral or what kind of functions you want to compute. So the answer to that question, I don't think changes when I revolve this around a different axis. It's still about what variable do I want to operate in terms of. But now that if we're going to stick with dx rectangles, what has changed? The radius should change, but why has it changed? What's that? Yeah, so the axis rotation is different. So it's no longer a vertical line, it's going to be a horizontal line. So because I'm now rotating over a horizontal line, what kind of integral am I going to do? This has to be a disk. Disk or washer. Really, this truly is a disk method. So because of that, I don't have an inner radius. We just do pi from A to B of whatever the outer radius is squared dx. What are the bounds? Are they still 2 and 4? They should be, right? I have the same exact area that I'm rotating, and I'm using the same variable, so the bounds better be identical to what they were. What is that radius? Yeah, the y, basically whatever that parabola is defined as, so negative x squared plus 6x minus 8 all squared dx. So one thing I want to point out, it came up before class today, is that we're stopping at the setups here. Are these integrals the same? The two things that we wrote down?
No.
Is there anything about them that is the same? What's that? The bounds, anything else? Right, so multiplying by pi. What if I were to actually compute them? Should they be the same? Why not?
One is a disc and one is a shell.
Well, one's a disc and one's a shell. It's not quite enough.
The distance it's traveling around the circle is different.
The distance is different, but also I'm not even making the same solid, right? Yes, the areas are identical, but what am I doing with this area? I'm either wrapping it around this to make like this donut shaped thing, or I'm wrapping it around the x-axis to make like this egg-shaped thing. So the areas are the same, yes, but I'm doing something different with that area. So I'm not guaranteed to get the same volume. Go ahead.
If that function allowed us to do a dy,
Mhm.
they would be the same.
Right, so that is, if I were to set this thing up, so it just was sticking with this where I'm wrapping around the x-axis. If I were to do a dy rectangle and set up that integral, it would have to give me the same result as the one I just boxed in here. So it's not enough for the areas to be the same. It has to be, I have to be revolving over the same line to be making the same solid as well. How are we doing? We happy with volumes? Okay, let's do one more and we'll get away from 3D stuff. All right, what should I do? I should graph it. So I know what this looks like. Sideways parabola. Sideways left or sideways right? So I know I'm going to be bounded by x equals 4 and y equals 1. Where is this parabola? I believe it's something like this. So a lot of different curves and lines here. Where's the area that I actually care about? Yeah, it's going to be here, right? Around where? Y equals 1? Oh, so this is not really part of the boundary. That's my axis boundary. Okay, I think that's a good enough graph. I don't know how accurate it is, but I feel like we're organized now. I know where I want to rotate it. What question should we answer next? dx or dy rectangles? Why do you think dy?
Because we already have it as a y as a function.
Okay, so basically the same reasoning we used for the last one is we have this thing. So let's just write down the lines or write down the functions or the equations that bound this area. I believe they are x equals y minus 3 squared and x equals 4, right? Is that it? Yeah, that should be it. So we have everything we need just from those two lines. If we use dy rectangles, I want to express everything in terms of y. So let's continue with this. What kind of method am I using here? This gives me shells. So if I wrap that thin rectangle, which is a dy rectangle, around the line of rotation, which is y equals 1, I'll get shells. And one more, I'll put like one more bow on this. What gives the thickness of this cylinder? Or what is the thickness of this cylinder? Did I hear someone say y or dy? Should be dy, right? So that dy, that tells me it's a thin cylindrical shell, which is basically what the shell method is based on, is those thin shells with like dy or dx thickness. So setting up shell method from y equals a to y equals b of 2 pi radius, height, what is the radius of these shells? It's what, minus 1? So here's the rectangle I drew. Let's say this has a y value of b. How far is this rectangle I drew from the line we're going to rotate it over? It should be b minus 1, right? So I moved up the axis rotation. So I think typically what you would expect is that was a rotator this around the x-axis. I moved it up 1 unit. So the radius is not y, it's 1 closer, y minus 1. What's the height of these rectangles? Y minus 3 squared. Is that enough? It should be 4 minus that. So let's write that down and let's talk about why the height and the radius are what they are. Why is the height not just y minus 3 squared? Yeah, there would be no. Yeah, I don't know if I would get a. Yeah, I don't know if I would have a left end and right end here. Something else I want to point out is this. Something we said a while ago. I'll ask it again. When we're doing shell method, should the radius and the height always be perpendicular to each other? So in this case, we said radius was a change in y, right? Does it make sense then for the height to be a change in x? So these cylinders are laid out like, yeah, it's kind of laying on the side. So it should make sense that the height is some horizontal measurement. If it's some horizontal measurement, then what I'm really doing is comparing x2 and x1. So basically no matter where I were to draw a rectangle here, where's the right end of these rectangles? Just 4? X equals 4? So I think that's why this is in that position. The greater end, like the greater value location of these rectangles, the right side of these rectangles is x equals 4. Where's the left side going to be? The left side comes from the parabola, which is this thing here. Questions on why the radius and the height are what they are. One last thing we need to do to finalize this integral. What is that? Find the bounds. What are the bounds? 1 and 5. How'd you get 1 and 5?
Step 4 equal to 3 squared, solve for
Right.
0.
So one thing we need to do is basically the y values we need are going to be wherever this point is and wherever this point is. We didn't find that yet. So the way we find that is by setting our x's equal to each other. So y minus 3 squared equals 4. If I square root both sides, what do I get? Y minus 3 equals plus or minus 2. So y equals 3 plus or minus 2, which is 1 and 5. So really the way I drew this wasn't very accurate, right? Really this parabola extends all the way down this axis rotation. But that's fine. I didn't need this perfect scale drawing. I just needed to kind of help me organize where things were. So now can I write out what this integral should really look like once and for all? So the integral, or 2 pi times the integral from 1 to 5 of the radius, which is y minus 1, times the height, which is 4 minus y minus 3 squared dy. So a lot of different like kind of special considerations for this one. Both the radius and the height we had to kind of adjust because we had these vertical and horizontal lines that we were either rotating over or that were offsetting what our graph looked like. So yeah, let's take all the time we need to talk about how we answered all these different questions. Like, so how we got the bounds, how we got the radius, how we got the height, why we did shells instead of discs or washers. How are we feeling? All right, so did a lot of 2-dimensional stuff with areas between curves, did a lot of 3-dimensional stuff with volumes. So what's next? So let's find lengths. So back to 1-dimensional lengths of curves. So let's talk about kind of how to set that up. We only have a few minutes, but we can kind of get into the motivation of these things. So I'm going to show you a curve from x equals 0 to x equals 1. I want to find out exactly how long that is. So how can we at least come up with an estimate for how long that is? Any ideas? Think back to, I mean, the first thing you were probably asked about things like this was areas. How did you go about finding, like, guessing or estimating the areas underneath curves like this? Riemann sums, right? So basically what Riemann sums allow you to do is it allows you to basically trade your very weird looking function, your weird looking graph, and trade it in for rectangles, shapes that you understand really well. Can we do the same kind of thing here with lengths? Can I trade these lengths in for lengths that I understand a little better? So let's think about this. What if I split this thing into, for now, we'll say 5 intervals. How might I at least come up with a guess for how long it is from this point here to this point here? Okay, so I can do that. So clearly not a straight line that joins these 2 points, right? But if I were to join them with a straight line, can I find the length of that? So that's basically the motivation for finding arc length here is I'm going to think about these very non-linear lengths as straight lines and find their lengths. How do I find lengths of straight lines like this? Slope? Do I need the slope? How would I find the slope? So let's say this. Let me come up with some numbers here. 0.2, 0.65, and what's this? 0.4, 0.45. Could I find out how far apart those things are? How do I find the distance between them? What minus x1?
X2 minus X1.
So that'll give me the distance in the x direction, but I want the pure distance. I want to know.
Y2
X2
y1
minus
over
X1
X2.
squared plus Y2 minus Y1 squared. Pythagorean theorem.
Okay, so you're setting up Pythagorean theorem, which is really all about what kind of shapes? Right triangles. That's essentially what you're kind of setting up here. I have a change in y. I have a change in x, which you're calling x2 minus x1. If I square that, then I also square the change in, not y squared, y2 minus y1 squared. So basically, to find the distance, I need to square root that whole thing, right? So that gives me the hypotenuse of those triangles. So really, when I'm asking for the distance there, what I'm really looking at is the hypotenuses of these really small right triangles I'm going to make. So how many right triangles am I going to make for this curve, the way I set it up? 5. How many, what should I be doing in order to get my arc length, get a really, really good estimate for my arc length? What's that?
You're still talking about that equation.
Sum them all up, right? But that's going to give me 5 hypotenuses. Is that going to be correct? How many should I use? An infinite amount. So basically, I'm taking the Riemann sum and I'm adapting it to not find area, but the length of these curves that are not straight. They don't have straight lines in them, but basically I'm going to use straight lines to kind of estimate them. Or not really even estimate them, but to come up with them exactly. So let's just take like one of these intervals. We'll do the same one from 0.2 to 0.4. Or do I need to stop? I don't think I do. So we talked about how to find this length. Let's call this dy. Let's call this dx. And let's call this distance right here, we'll call it s. From Pythagorean theorem, we get this, right? S squared equals dy squared plus dx squared. Or from there, that s equals the square root of dy squared plus dx squared. So I'm going to do something here that might not make a ton of sense, but hopefully I can at least convince you that it's legal. I'm going to multiply the inside of this thing, the inside of this radical by 1 over dx squared. So over dx squared over dx squared. If I do that, then what else do I have to do? multiply the outside by just dx squared. Are you convinced that what I've done is legal? Maybe you can't see why it's useful, but is it legal?
Square root of dx over dx squared.
Basically, that's what I did, is I multiplied by the square root of dx squared over dx squared. So why have I done this? Here's why. Basically, my arc length becomes this. What's dy squared over dx squared? That's dy over dx all squared. What's dx squared plus over dx squared? 1. What's the square root of dx squared? Dx. So basically, if I want to find the arc length over this whole interval, then I don't want to just do one interval, right? I want to add all these together. Is there a thing in calculus we use that adds a bunch of things together? That's what an integral is essentially. It takes a bunch of very small measurements and adds them all together. Oh, I picked a really good place to do this calculation. So basically, here is what we kind of motivated. If I want to find the arc length along a curve, this is the integral we're setting up. This integral from whatever your bounds are, from x equals a to x equals b of the square root of 1 plus the derivative squared. So it's 11 o'clock. We'll talk a lot more about that next week, but I at least wanted to get slightly into it. All right, have a good weekend. Or I'll see you in office hours in about an hour.